In the previous unit, we saw a list of different types of available monitors. Some basic properties of monitors are shared between several monitor types, so we'll start by going through these common settings and general tips for using monitors. Monitors can be added from the Monitors drop-down menu in the main toolbar. The Global Properties window can also be opened from this menu. Global properties are used by all frequency domain monitors by default. In the Global Properties Edit window under the Main tab, you can set the frequency or wavelength range over which to record data, as well as the number of data points to record over the specified range. By default, the data points are spaced evenly over the frequency range, but you can also choose to record data at points evenly spaced in wavelength instead. In the Advanced tab, you can set the desired sampling rate in time. By default, this is set to the Nyquist limit based on the frequency range of the source. For linear simulations, this sampling rate does not need to be adjusted. However, if running nonlinear simulations where you want to measure fields at higher frequencies than the source frequency range, the sampling rate can be increased to get accurate frequency domain results. There are other common settings that only apply to some monitor types. This is a frequency domain power monitor. Under the General tab, one of the common monitor settings is the simulation type. Under the drop-down menu, you can specify whether the monitor should record data if the simulation region geometry is 2D, 3D, or both. By default, this is set to all, so the monitor will always record data regardless of the simulation region geometry. You can also choose to override the global monitor settings. Under the Geometry tab, you can set the monitor type, which sets the monitor orientation and geometry. The available options may vary depending on the monitor type. But for this monitor, you can choose to set the monitor to a point monitor to record data at a single point in space, a 1D linear monitor along the X, Y, or Z axis directions, a 2D surface monitor with surface normal in the X, Y, or Z directions, or a 3D monitor which records data over a rectangular volume. The monitor positions and spans can be set, and below that, downsampling can be set. Downsampling allows you to reduce the amount of data recorded by the monitor. For example, if downsample X is set to 2, this means that the data will be averaged over every 2 mesh cells along the X direction, reducing the amount of data recorded and the memory required by half. A setting of 1 means that no spatial downsampling is applied. Under the Data to Record tab, you can set which field components to record. These include E and H field components, pointing vector components, and output power, which is the net power flowing through the monitor, which can be calculated by integrating the real part of the pointing vector normal to the monitor surface. Under the Advanced tab, you can select the spatial interpolation options and the sampling rate in time. Click OK to accept the settings, and you can see the yellow outline of the edges of the monitor in the CAD viewports. Monitors are always represented in yellow in the CAD view. Here is some general information and tips to keep in mind when setting up monitors. FDTD Solutions is the time domain solver, so frequency domain monitor results are obtained by applying a Fourier transform to the time signal. To review the details, see the FDTD algorithm section of the course. If symmetry is used in the simulation region boundary conditions, monitor data will be unfolded according to the specified symmetry to give the full field profile. However, any monitors that are contained completely within the shaded side of the simulation region will not record any data. Monitors can extend outside of the simulation region, and monitor results are automatically truncated at the boundaries of the simulation region by default, although it's possible to set the monitor to record data within the PML absorbing boundary region. Any monitors located outside of the simulation region will not record any data. Adding monitors to a simulation does not increase the time that it takes to run the simulation, except when using a movie monitor, since the movie monitor will save data and generate the movie file as the simulation is running. Adding monitors will increase the memory required to run the simulation, as well as the size of the saved file after running the simulation. To make sure that your system has enough memory to run the simulation, you can generate a memory report. You can reduce memory requirements by using 2D or 1D monitors instead of 3D monitors, recording fewer frequency points, using spatial downsampling, or selecting fewer field components to record in the Data to Record tab. For example, if you're only interested in getting the transmission through a monitor, you can choose not to record the E and H field components and only record output power. Additional information about advanced monitor settings such as partial spectral averaging and apodization can be found in the links listed below.